So ask. What were you saying? Say it one more time.
Well, I was saying, I didn't understand what S meant because to me, it never said like S equals this. So it's
Okay.
this.
So so S is the standard deviation of a sample,
Okay.
and when you see sigma, that's the standard deviation of the population.
Population.
Right. Yeah. No, I knew what sigma meant, but in the equation, like I had like S divided by the square root of n or whatever that is.
Yeah. Because we're dealing with samples.
Of the standard deviation was like the standard deviation with the line above it. Does that make sense? So they've changed.
Yeah. So
that's where I got confused.
Well, so what the difference is that when it's sigma, it's the standard deviation of a population, and then the S is the standard deviation of just a single sample.
Right. But I thought that was with the one with the zero with the, like the cursive zero with the line above it. I thought that's what that was.
Yeah.
So now they've changed that symbol to S, so they're the same symbol. Does that make sense?
They're a little different. They're a little different, yeah, but essentially they are the same.
Okay. That's where I got confused. So. Okay.
Alrighty. Well, if no one has any other questions, are you guys ready to go ahead and start the test?
Yep.
First, right? Yeah.
Yep. Lesson 10.
Or we can mix it up if you really want to, but.
No, I'm okay.
Yeah, I've already started lesson 10, so the quiz.
Okay.
I'm sorry if I get spaghetti all over my face. I'm really trying to eat nice.
That's fine.
That's my computer loading here. We answer the first two questions ourselves as usual.
Yep.
Yeah.
Hold on, my computer's not really slow. Just bear with me. Okay, so let's start with question 3.
Yep.
Alrighty. I say everyone, so find the margin of error with the 90% confidence interval and the standard deviation is sigma and n25. So I say everyone do it on your own, and then we'll see what we all come out to.
I just gotta pull up that equation again.
Yeah, I just gotta get paper out. Okay.
The margin of error, are you guys using the equation m equals 2 times standard deviation over the square root of n?
No, I'm using the exact by putting it in the Adobe, the applet thing. And then that's what it said to use.
I guess you could. There's a couple ways to do that. Let me see.
Because I know the z-score
I'm solving. Go ahead.
The z-score is 0.126.
No, wait, for 90? Z-score is 1.645.
I got 0.126
126 for what?
for
The
90.
Z-score?
But wait, hold on, I did that wrong. Because it's the middle part, right?
Well, it's just that, do you guys know the level of confidence table?
Yeah, no, I got it.
You guys got, and because just going back to the lesson, it's
Okay, yeah.
1.645, right?
Yeah,
Yeah,
it is,
no,
yeah.
I did it wrong. I had the outsides clicked, not the insides.
Gotcha. I thought I was freaking out there. I'm like, okay, I thought I understood this. So the
Okay.
formula I use, Seth, I would use z-score times sigma over n squared, or square root of n.
Oh, okay. So m equals
just
the z sigma over standard deviation.
So Mark, yeah, m equals z times standard deviation divided by the square
Okay.
root of n.
Okay, I see.
Okay, I got an answer when y'all are ready.
Just give me 1 second. Sorry, I just wanted to check in the system as well, make sure I have it right.
I got an answer as well. Well, I lost my.
Okay. I got 16.45.
Mm-hmm.
Yep.
And how did you guys do that?
I did the 1.645 times 50 over 5, which is the square root of 25.
Okay.
Over the square root of 25, which is 5. Yeah.
Okay, that's what you did. That's what you did as well.
Yeah.
Okay. Cool. Hold on, I can't find. Oh, there it is. No, it's not. Oh, there it is. Okay, sorry guys. All right. Going on to number 4.
Which of the following statements is true? Standard deviation squared is the interval expression of the sample mean. The sample mean is the point of estimator of the mean. Mean is the point estimator of the mean sample. Standard deviation is the intervator estimates standard deviation squared.
Okay. I think it's x bar is the point estimator of mu.
That's what I was thinking too.
So is that was the second option for you guys, right?
Yeah.
Okay.
That down.
Well, let me look.
Yeah, so if you want to double check that for us. Yeah, because I took on my notes right here. I have x bar as a sample mean and then parentheses point estimator.
Yeah. Yep.
Okay. Gino wants to construct a 95% confidence interval at a GMAT score. She knows that the standard deviation is 113. She collects a random sample of a sample size of 64 and computes a mean of 52.6. Use this information. What is the point estimate for the true GMAT score? Okay. What is the formula for that? It's just the z-score formula, right?
Yeah, so that's 1.96. Yeah, 1.96. 0.
Now I'm drawing a blank.
Okay. What is the point estimate? Yeah, me too. I'm trying to remember. I don't know.
So that's in
Would it be
3.1.
36 minus, sorry, not 36, 46 minus,
Where are you getting
No.
46? Where are you getting 46?
64. Sorry.
Oh. What is the point estimate for the true Gini score? Oh, the answer is 526. Remember, we were just talking.
We just talked
Okay.
about how that's mu. X to
Yeah.
the point of, well,
Well, they were using fancy wording, so we were just thrown off.
Yeah, come on, guys. Come on.
Okay.
We're better than this. Come on. Okay.
well. So
Answer is
we're getting the
520.
So we're getting the mu. Is that correct?
I think we're not solving for me right now. I think we'll probably
Okay.
get asked that
Is it-
question just a sec.
Yeah.
Okay, now margin of error formula again. So z of point
With
169 or 196. What was this? I hate having to scroll up and down, up and down.
Yeah.
Alrighty, let's see if we all come up with the same thing.
Okay, I'm done.
Okay, let me see here. Okay, guys, I got 14.125. Or sorry, scratch that.
No.
I got 27.685.
Yeah.
Yeah, I was like, 13. Whoa.
Yeah, I was reading
Yeah.
the wrong number. Okay.
So is it to the third decimal spot?
The directions always say do that unless otherwise.
Yeah, it said it up at the top.
Yeah.
Remember to round up the decimal point.
Yeah.
But
I
it
just
doesn't
wanted-
go further than that.
I just wanted to recheck because on the test, I think I missed one because of some issues of it asking me the percentage or the probability of something, and I put the third decimal spot, but they wanted it in
no.
whole, but it didn't specify, so I don't know.
Yeah.
So I'm
I've
putting
used on
down.
that test. That was,
I got a B plus, so
not bad.
yeah,
Okay,
I could
lower
have done
level.
better, but
Okay, so lower level.
So that's
for number 6, I did
That's-
27.685, correct?
that's the mean minus the
So,
27, right?
or is it the mean minus half of that? Or no, it's the mean minus the 27. You're right, minus
Yeah.
the 27. I always think it's because the margin of error is half of the total spread, correct?
Right. So I got an answer.
Right, sorry, give me one sec. So we're looking for the lower interval?
Yeah,
Lower level. Okay.
So
the low one.
so 526 divided by what number?
Subtract.
No. Subtracted.
Oh,
Ready, Seth?
no. So of what number are we? Of lower limit confidence interval. And are we subtracting that from the standard deviation?
No, we subtracted from the
Understood.
mean.
No, we subtract the margin of error from the mean.
Okay. So I got negative 498.315.
It should be positive 498.3.
Well,
Yeah.
did you say?
Taking the mean and subtracting it from that number, from the
Oh,
20.
I thought you said take the margin of error and subtract it by the mean. Okay.
Oh,
Yeah, push it.
I may have. My bad.
No problem.
Do what we meant, not what we said.
That was my bad.
It was just a miscommunication.
Okay, number 8's the opposite, so you just add it.
Mm-hmm. I've got
Okay.
Oh,
Now I get these.
hey, for number 7, let's make sure we got it all right. We got 498.315.
Yep.
Yeah.
Okay. All right, and then number 8, we got 553.685.
Yep.
Yeah.
Okay, what would happen to the width of the what would happen to the width of the confidence interval if she increased her sample size? It would decrease.
Would it decrease? I'm trying to remember what I read. I don't remember what I was talking about the sample size.
Okay, so what would happen if the if the sample size increased?
Mm-hmm.
That means we have more data.
Mm-hmm.
More data, the closer we're going to be. So, and I'm just reading through my notes. It says, as sample size increases, the width of confidence interval decreases. So those have an inverse relationship where the confidence level.
That makes sense. Yeah, I remember reading that, but I remember talking about like the other stuff, like if this decreases. Okay, we're good.
Yeah. So what it is, if the confidence level increases, the width it increases. Those have a direct relationship.
Mm-hmm.
Those ones are. Right? It makes sense if you really think about it, but
yeah,
it's
it does.
So 9 is decrease.
Mm-hmm.
9 is decrease. You got it.
So what would happen to the
Okay.
width of the confidence interval if Gina changed it to a 0.99? Oh wait, no, that was just a dot on my screen. 99% confidence interval.
That's funny. There's a dot on my screen right there too. No, it would increase at that point.
Yep. Because the confidence level went up.
Yes. So it's a bigger spread. Okay. Question 11. Bright bulb light bulb company. What? Read that again. Bright bulb light bulb company is planning a study to access the average life of expectancy of their light bulbs. They know the standard deviation is 400 hours. And they want a 95% confidence interval. That's a huge standard deviation. Okay. Standard deviation of 400 hours, confidence interval of 95% with a margin of error of 50 hours. Okay.
So we're solving for.
We're solving for sample size. Okay. So let's all do that on our own. Seth, do you need the formula?
Is it the previous one that we used, the z times the standard deviation over the...
This one's different because we're solving for n.
So we're just doing everything.
So we're solving for n. So the formula on this one, it's the same one as the z-score. That's like the z times, standard deviation over, but you got to solve it algebraically. And because there's like a division and then it makes it really difficult because there's also a, what's it called, a square root. So what the formula that they give you in the textbook and in the videos, it is it's n equals z times, so this is all in parentheses, okay? So z times standard deviation divided by the margin of error. So you take that formula, so you got z times.
And then you have to square it.
Yeah, and then you square it. You square the whole thing after you square the whole thing after you
Yeah,
get
I
the
wrote it
answer.
down.
Okay, okay, good. But did you get that, Seth?
Yeah, so
So we have a 95% confidence interval. Well, was it 95? Yeah, so we take 1.96 times, is it 500? 400? That's insane.
400.
400 over 50. Okay. And then you square that answer. So 1.9.
Okay, I
got mine too.
246?
yep.
I round to the nearest whole. Okay, yeah.
So it's 246.
But did you guys get two? You guys get 245.8624?
Yep.
Yeah.
But 246. Okay, cool. Okay, new word problem here. Okay. The mean salary is mu. Looks like this was probably a review. So we got mu of 100,000. Okay, I'll just read it. The mean salary of actuaries is 100,000. The standard deviation is 36,000. You are interested to know what the mean salary for women actuaries, or you want to know if the mean salary for women actuaries is different from the mean population, but you are not sure if it is higher or lower. Set up a hypothesis test to find that significance, okay? You collect a random sample of 36 women's salaries and find X equals 101,000. Use this information for the next 3 questions. Okay. Alrighty, question 1 or 12. Find what is the paper. What is the lower limit of the 95% confidence interval? Okay. So lower limit.
That's 111,000 minus
Whatever.
the mean or the margin error is.
Yeah, which we gotta find first. Do we want to do it on our own and then see?
Yeah.
Yeah, hold on. What is the lower limit?
95%.
95%.
Wow, that was. And we're also rounding the answer to this one as well.
To the nearest whole number? Yeah, okay. But don't round until after you get your answer.
Correct.
Yep.
Thanks, Steph, for the reminder. Okay.
Someone had to say.
Okay, I got.
Wait. Don't tell me.
Okay, I got my answer too.
Looking for the lower limit. Okay. So I got 99.002.
Point?
Yep.
Or do you-
Not point, comma.
Dang. Yeah, that's what I got.
99002. Okay. So now just add those two, I guess, right?
Yeah, now we add them for the next one. I've got that in.
Okay. I got 2998.
What'd you get?
122,998.
Sorry, I just heard 998, and I was like, you're missing a few numbers.
So
So 122,998. Okay. Good job, guys.
1, 2, 2, 9, 9, 8.
Got it. Okay, what are 3 requirements that need to be checked when computing a confidence interval for the mean? They are sigma.
Okay.
All the above.
Well, we know sample, random sample. All the above.
Yeah.
Okay. Because I know it's simple random sample, and I know it's X is normally distributed, and then I'm pretty sure its standard deviation is known. So, is all
Sounds
good
good.
on this?
Yep.
Yep.
Okay, go ahead to submit. You'll have to let me know how he did because my computer's going
100.
really slow.
We got 100.
Alright. So chapter 11 was a little bit more tricky. It's pretty much the same thing, but
Except for
it's just a little more tedious because we have to just go maneuver through those annoying spreadsheets.
mhm.
Okay, good job, guys. All right, let's go to lesson 11.
Excuse me.
And while we're pulling that up, have any of you guys looked at the group projects that we're supposed to do soon?
Nope.
No.
All right,
Have
so
you-
I looked at
Saying
it.
it 1 week at a time.
Yeah, so I think we should. I looked at it a little bit, but within the next 2 weeks or so, I think we're starting in 2 weeks.
Okay.
I think of ideas of tests we can do because it's going to be a doozy.
Sorry,
I think.
what was
I
you
don't-
kind of cut out there? Think of what?
Oh, just think of ideas of different tests we can do. I don't know because we have to come up with a test and we have to test it and
What are we testing? Sorry.
something. I don't know. We have to come up with like number of green Skittles and different bags of Skittles. You know, the things we got
That's a
to.
good I like that idea.
Yeah.
So now we all have to purchase Skittles.
Yeah. So just think of go over and read the assignments within the next 2 weeks and just kind of just keep it on your mind of things that we can do.
Okay.
I don't. So it's not such a tedious task when it comes up. But okay. Group meeting quit here. I gotta turn my AC on. I'm dying in here. Give me 1 sec.
Okay, no problem.
We are all dressed up all fancy like. And you said the S equals standard deviation, right?
Yes.
Okay.
Of the sample.
Yeah.
Okay. Are you guys starting chapter 11?
Yeah.
Yep.
Okay. I'm slacking here. 1 sec.
Okay, we forgive you.
Thanks. All right.
You're welcome. I'll do what I can.
All right.
Okay.
Sorry, my. Oh, what? Oh, my computer's not plugged in.
Oops. Sorry, you guys have to look at like my nasty room right now. I haven't done laundry, or I need to do. I've done the laundry. I just haven't put it away.
Oh, that's okay. I finally have a chair to sit on, so I'm happy.
Your microphone's sounding. I don't know what you did to fix it, but
Oh, it's sounding better?
yeah, you're not as far away.
Oh, my guess is it's because my laptop used to be on the ground, and so I don't know if the mic is actually taking it from the headset or if it's taking it from the computer, but I don't know. I'm glad it's better though.
How's it coming, Thomas? Oh, Thomas is gone.
All right, I guess we'll start without him. I'll answer number 1. You do number 2.
Done. Does that mean it's not recording then anymore if he's gone?
Yeah. Oh no, it's still
man.
live. No,
Is
it posts that it's still live.
But wasn't it
I
live
guess.
before?
Yeah. Well, no, it says it's offline when it's not recording. So we'll give it a minute. We'll, I guess, wait for like 3 minutes. If you can't get back in about 3, we can just continue.
How's your dinner?
Good. I'm just right now just having a smoothie. So.
Oh, I'm back. Sorry about that.
Oh, no problem.
Okay. Sorry, my computer died. I had to plug it in for some reason. So. Okay. Let's see here. All right, questions 1 and 2 we do by ourselves.
Yeah, we're all on question 6.
No.
I'm just kidding.
Okay. All right. Distribution applet. Do you guys have you guys used the T distribution applet yet? Because I just don't think we don't need it, do we? Because I was trying to figure out when I need it. So, but I don't think we do. So hopefully nothing comes up. Okay. In previous lessons, we have assumed that the population standard deviation was known. In this lesson, we are making inferences. In this lesson, we are making a different assumption about standard deviation. What has changed? We assume standard deviation is unknown. Is that what it is?
Well, we know it's unknown. Isn't it 1? Hold on, let me go back.
I don't think so.
Let's see.
Because I don't remember reading.
Da-da-da-da. I don't think we assume that it's unknown because we know it's unknown.
Yeah, that's what I was thinking, but I think it's just verbiaged weird. So I say we go with that one, and then if we get it wrong, I mean, we have another shot.
Right.
And then if it's either that one or we assume it's 1. So, but I don't think it's 1.
So
I'm
in the
just
reading,
reading.
it says, in the markable place of where Goset found the appropriate distribution to use when standard deviation is unknown. So it does mention that, but I don't really see in the text where it's saying.
Because it's not 1 because we use S instead of sigma. That's why we don't use the population standard deviation. We use the sample deviation.
Okay.
So, and then we use the.
I don't like it when they word
Yeah.
things funny. I don't think that's okay.
Well, I hate when they say what the data are congruent. Because they use that a lot. Remember that I was saying that the grammar is incorrect, but they keep using it, so I think it's probably correct. It just reads really weird. Okay. So let's see here. Okay.
Standard deviation is unknown.
Okay, for the next two questions, let the null and alternative hypothesis be 8, mu equals 8, or mu is greater than 8. Assume that the standard deviation is mu is not known. Beckle collect a sample size of 9 and compute standard. Okay. And question 4 is no, right?
Yeah.
Okay.
That was easy.
Because it says assume the population standard deviation is not known.
I'm trying to pull on one on us, guys. All right, what is the t value? Okay. So the t value is the same formula as the p value.
So it's the mean minus mu divided by the standard deviation divided by the square root of n.
You nailed it.
Cool.
Wait, what?
So
we're solving t value, and t is x bar minus mu divided by s divided by the square root of n.
Oh, okay, that makes sense.
So I think that was p. I think.
But that makes sense.
I think was it the same as the z-score, or the I think it's the same formula, not as the p-value as the z-score. That's what it is. Okay.
And mu is 8, right? That's what we're assuming.
Yeah.
Okay.
So it's 11 minus 8 over, what is it? 6 divided by 3.
Yeah.
2.
Okay. I got an answer.
Got 1.
Do you want this?
Is that what you're saying the answer is?
No, it's 1.5.
Yeah, 1.5 is what I got. These ones are.
They won't even let me copy it.
Oh yeah, because it's a test. Let's copy it. So annoying.
Well, I was gonna put it in the thing.
I know, me too. It's irritating. Goodness. All right, well, let's all take our time and make sure we type it in correctly.
How do teachers gonna make things so hard?
Yeah,
Well,
I don't think it's him that does it.
I just wish they had provided that spreadsheet.
I know.
Because now I'm having to look it up.
What's,
I saved it on my stuff.
Yeah, I can look through my folders, I guess.
yeah. Oh yeah. So wait, is there there's a spreadsheet for that one?
Quantitative description statistics.
Statistics.
Oh yeah. Is there a spreadsheet for that data?
Oh, maybe.
Oh, I thought that's what you guys were saying.
Body template.
Body temp, most likely.
Probably.
I'm just gonna type it in. Wait, I found it here. Oh yeah, I found it.
Is it the same?
Yeah, let me double check.
Can you post it in the chat?
It is not the same.
Okay.
There's a lot more data in this. Let me see here, because it might be all the same up to a certain point. Because it only it's the same up to a certain point. So that's funny. Someone can count how many numbers there are there.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18,
18,
19, 20.
20. Okay, let me,
Here, I count that 1, 2, 3.
yeah, I got 20. Let me just go to the spreadsheet and see if it's the same. Yeah, it's the exact same. So I'm just gonna run through everything real quick. Okay, it's the same. So I have the spreadsheet here. I'm gonna see if I can just copy these figures into the chat, and you guys can use those figures to copy and paste over.
Okay.
Oh, sweet, it worked. If you guys want to look at those numbers, just verify that those are correct.
Only if I could highlight it.
Is it not letting you?
Nope.
Here, I'll email it.
Yeah, or if you just send us that document.
I don't have it.
The
So I
Excel.
don't have it saved. So I'll just try to see if I can email it to you guys. So Seth, your email is S Benson, right?
Well, S.J. Benson, yeah.
S J Benson. Oh, okay, there it is.
Wait, are you talking about my school one?
Or I'm just.
The Gmail works perfectly.
I'm just going to type mine in manually. You don't have to email it to me.
Okay. Alright.
Yes. S.J. Benson 13.
I think that's what I did.
Okay, I got it. It's not gonna work.
Alright, let's just punch it in manually.
Yeah.
Have you finished doing that? Have you?
I'm still working on it. I'm almost done, though.
Oh, okay. So I just want to make sure that we have the same mean. Oh, that's the next question.
Okay, I'm done.
Okay, what'd you get for your mean?
I got 8.3.
Okay, I have 98.22.
Yeah, I got 98.22 as well.
Hold on, let me make sure I put the numbers right.
If you want, I'll say the top one and go down the list. So then you don't have to look back and forth.
I've got them open up right next to each other, so.
Oh, okay.
We want to make sure that we're using the right numbers.
Yeah. My numbers matched up. Seth, did you just punch them in from the test?
Yeah. I just typed them in manually because it took too long.
I was trying to find the shortcut. It's taking way too long. Okay.
Oh, I didn't type it. I just let me just double check mine.
Yeah, me too.
My numbers match what the thing gave.
I really should have provided a spreadsheet here.
So I have. Let's just read our numbers together. So.
Okay, hold on one second.
Wait.
Let me pull it up. Okay.
98. 99.6.
Okay.
97.8.
Okay.
97.6.
Okay.
98.7.
Okay.
98.4.
Okay.
98.9.
Okay.
97.1.
Okay.
99.2.
Okay.
97.4.
Okay.
99.1.
Okay.
96.9.
Okay.
98.8.
Okay.
99.9.
Okay.
96.8.
Okay.
97.
Okay.
98.7.
Okay. You cut out there. What was that?
97.6.
Okay.
97. Okay. 98.7.
Yep.
98.2.
What I got?
Yep.
Why aren't our means the same then?
What's your mean again?
98.3.
That's the median.
Oh. Hold on one second. Let me double check that. Okay. Oh yeah, I got 98.22. You're good. You're like, she's so stupid.
Come on. Just kidding. All right. 98.22. Okay.
Okay.
And guys, I'm using the quantitative inference procedures spreadsheet because it gives you the same.
Yeah,
You can
that's
use
what
that.
I'm looking at too.
Okay.
Yep.
Good.
Same.
I just wasn't looking at the right number.
All right.
So for question number 6, we got 98.22.
Yeah, 98.22. So I don't even see the 92.8. Where were you getting that? Where's the median?
98.3. He did for the She did for the median.
Oh, I don't even see a median option.
It's in between Q1 and Q3.
Oh no, I'm using quantitative inference procedures. I'm using a different spreadsheet.
Oh, okay.
Oh, that makes sense. I was confused. Okay. All right, because it gives you the same answers, and we're going to have to pull it up in just a second anyway. All right, number 7. Did you guys get 25?
No, standard deviation, I got 90.92201.
Yeah.
Oh, where did I get 25? That can't be correct. What was your guys' standard deviation?
0.922.
0.922. Okay. That's what I got. Okay. Hold on. All right. Question number 9. What is the p-value?
What? You mean 8?
The p, or what is the p-value?
Aren't we on 8?
Yeah.
Oh yeah. Sorry, for some reason I skipped that one. My bad.
I was like, wait a second.
Come on. Just kidding.
All right. All right. So you said it was. So number 7 was 0.922.
Yeah.
Okay. Find the t-score. Okay. T-score.
And the sample size is 20, right?
Sample size is 20.
Okay, I got my answer.
Okay, give me just a sec. Cool. For the p-value, you're gonna have to use the applet. Or no, we're doing t-value.
T,
Sorry.
yeah.
So do we do what's the inside or we do what's on the inside, right?
I'm trying to think right now. I'm drawing some brain farts here. Or just give me a second to work this over in my head here.
Okay.
You're talking about the t-score?
Yeah. No, t-score. I know the formula, but because I'm plugging it into the system because there's a formula in the system that just solves it for you. What was the confidence level on this one?
No confidence level needed.
Oh, this is just a review.
That's what the t-score is, right?
Yeah, but I was just curious what it was.
Oh,
Isn't that what we're trying to find out?
Oh, there isn't one. No, we don't find the confidence level.
no.
Isn't that what t-score is though? Like when you really think about it?
No.
Okay.
T-score.
Can you have a negative number?
For T?
I think so.
Yeah.
Well,
Okay.
oh, I did that wrong. 1 second.
Seth, did you get negative 1.07?
No. I got
Or sorry,
negative 1.43.
Yep.
Hold on. I'm doing something wrong here. Give me just a sec.
Okay.
I screwed something up. Sorry, guys. Just give me a sec. I apologize.
Oh, no, you're fine. This happens to me all the time, and you guys have to wait for me all the time. So it's like,
I know I'm all off. I screwed up my spreadsheet.
oh, you made an Excel sheet that did this for you?
Well, they provide one.
Oh, I missed that. I need to go back and look at that.
Yeah, I'll send you guys a link.
Just been doing it all in my head.
Okay, see now I'm getting the correct answers. I just screwed something up. I made the calculation off. So, are you guys getting the t-score of 427.903?
No.
I got negative 1.843.
Me too.
Oh, hold on. I gotta plug in the correct hypothesis. Okay, my bad. What was? So maybe the spreadsheet isn't as helpful. Just kidding. I'm just using it really incorrectly. Okay, it was hypothesis 0.8, or it was 98.6. 98.6. Oh, so you guys got negative 1.843?
Yes.
Hallelujah. Okay.
That was wrong.
I just kept plugging in the wrong. So how it works, there's so many things that you got to plug in. You just got to make sure everything is plugged in correctly. Negative
Right.
1.843.
Okay.
Negative 1.843. Okay. So now we solve the p-score. I have the p-score already because the spreadsheet gives me the p-score. Hold on. I just got to make sure I'm doing. So we're trying to find out if it's less than or greater than. So. We think it's less than. Okay. We think it is less than.
Where are you at?
It's just spreadsheet. I don't know.
I was like, where are you talking about this less than, greater than?
Oh, because that's important for the p-value.
I thought the p-value, you just plug it into the Adobe app. Well, the T probabilities. Isn't that what it is?
Yeah, but you got to know where to highlight.
In the middle, wouldn't you?
Not necessarily. It depends on if it's less than or greater than.
Yeah, didn't they want you to do mu is less than 98.6?
Yeah, so you highlight everything below.
Below.
Oh, okay. Well, okay.
No, it's confusing.
Everything below the first one or both of them?
So we're doing the first one because it's negative 1.843.
Okay. So then I got the wrong answer. Okay.
What do you guys get? I got 0.040.
So
I got 0.081.
wait, so for the z-score, you guys put negative 1.96?
No.
No.
For the Z
Oh, it just changed
score,
it.
I put negative 1843.
Yeah. Here, let me plug it into the applet real quick and see what I get.
It just like changed. Point 0.0327 is what I got. So 0.033.
I didn't get that.
Negative 1.
So t-score is the same or similar to. Oh, actually no, never mind.
Wouldn't it be that?
How many degrees of freedom do we have?
I don't think that matters. For sure. Yeah.
Because they did provide us that.
This degree of freedom is 19.
Do we need to add 19 or?
So the area, so put in 19 for the degree of freedom,
Okay.
and then you get 0.040.
Well, 0.041 if you round it.
Hold on, that's where I'm messing up. Hold on a second.
You're right.
What is the degree of freedom?
19. So the degree of freedom is always 1 minus n.
Oh, okay, so I got 0.041.
Correct.
Okay.
Oh yeah, you got to be careful because.
That's what I missed because I was like, I don't understand. Forgot about the degrees of freedom. Okay, we're good.
So yeah, honestly, I think if we put 0.040 or 0.041, it would be correct because we'll do 0.041 first, see how that works because this spreadsheet says 0.04048, so it's like right there. It's just this one rounds differently.
Yeah.
This one rounds to the fourth. So I think there's some that could just be off by 0.0001. I don't think he marks you off for that. I don't think the system does. So either way, I think we're good.
Yeah, because that
So 0.0.
the 5 could have been rounded, so it's already been rounded.
Yeah.
You don't do it. Yeah. Okay.
So, but we'll just go with what that. we'll just go with what that says, and if we get it wrong, we know what we did wrong. So 0.041.
Right.
But we've been in situations like that where I get an answer 0.001 off from what you guys got, and we just went with what you guys got, and I mean it was the same answer, so it's not any different.
Yeah.
All right. So number 10, is that what we're on? Yeah. So we hypothesis.
We reject or we fail to reject?
We reject.
We fail to?
No, we reject it.
Why do we reject it?
Because 0.04 is lower than 0.05.
Okay.
Do you remember alpha?
Yeah.
Okay. So alpha in this one was 0.05.
So we reject the null hypothesis.
You bet.
Cool.
Reject it like drop it like it's hot. Okay, another data information.
And that we gotta manually enter in.
Okay, I have the baby boom spreadsheet up, so I'm just gonna punch that in. Let me know if you guys get the same data. You guys punch it in manually, I'll do it this way.
Okay.
Okay.
What are we doing? Wait. Time between births. Is there 20 again? I think there's 20.
I got 21.
Oh, there's 21. What's the last number? Is it 61?
Yeah.
Mm-hmm.
And this spreadsheet is very temperamental. You guys get the p-value yet?
Oh, sorry. I didn't know we were solving for that. I thought we were still waiting for everybody to enter the data.
Oh, okay. So real quick, what did you guys get for the mean?
40.0476619.
Yep.
Okay. Sweet. Alrighty, so now we're just doing all of it in one step. So we got to find the t-score, and then we got to plug it into the applet to find the p-value.
So there's a total of 21.
Yeah, total of 21.
What's the margin error? Do we not have that? Is it just 0?
It gives it to us. A 40. Oh no.
No, that's the mean.
We don't
That's the
need the
mu.
margin of error right now, I don't think. We just need
No,
the
we
standard.
So, but don't we need that to find the p-value?
No, we need to, what we have, we don't need the margin of error. What we need is, so the t-value, so yeah, but we're finding t first. And
Right.
T,
No, I know.
no, but the formula for
I know.
t, the formula for t is x bar minus mu over s divided by the square root of n.
Right. I know. But
But
it's
you don't-
asking for the p-value, and don't we need a margin of error for that? Because that's how I got a different one than you did
No,
last time. I didn't.
well, with the p-value, what we put in, it's not the margin of error. What we need is the what was the word called? It was the degrees of freedom, which the degrees of freedom is 20. But for this one, we just need, it's just the x, for the p-value, once we find t, we just plug t into the applet, and then we highlight the far left and the far right.
Okay. So what would we put in the margin of error? Would it just be 0? Or the degrees of freedom? Sorry.
Degrees of freedom, that's 20.
How did you get 20?
So it's always one less than the number of than the
Never mind.
than the data.
Okay.
So last time it was 19 because we had 20.
That makes sense. Okay. Thank you.
Yeah.
That's what I was asking. I know I said margin of error, but that's what I meant.
Thanks for checking out. Okay, so I'm gonna do it by hand as well. Make sure I got it correct.
For t, did you guys get 0.006?
Yes.
Not that far yet.
Jumping ahead, Seth. Okay.
Well, no, I'm trying to get p.
So P, remember P was you plug the t value into, for P you plug the t into the applet. You know what I'm saying?
No.
Do you not know the applet that we were just using? The like the thing that we highlight stuff?
Yeah.
So you plug 0.0, wait, what was it?
I'm getting this wrong. What am I doing wrong?
Wait, do I highlight the left side or the right side?
Both. You highlight everything but the middle.
Okay. I got 0.9953.
Yeah, that's what I got.
Hold on, I got something different. I'm trying to figure out what I did wrong. Okay.
So I'm going to do it by hand real quick, make sure I'm doing it right, because I'm just looking what the system spits out.
Okay.
Was mu 40? Yeah.
Yeah.
Your standard deviation. And Seth, what was your standard deviation?
My standard deviation was 36.3558.
All right. So for T, did you guys get 0.00 or 59?
Yeah, 0.006 is what we got.
Freedom is 20. Okay, I'm getting a different number. I'm getting 1.
So you got to highlight the far right and the far left, but you can't highlight the middle. Make sure. So make it a big. It's a really small middle because it's 0.995. So change your t-score on the bottom to 1, and highlight the two sides and not the middle. Then punch in 0.006 again.
Okay. I got 0.995.
Good.
Okay.
Good job, guys. Just give me one quick second. I'm just going to double check something.
No worries.
0.
Oh, wait, so sorry. I know I'm kind of backtracking. Explain to me again why previously we rejected the null hypothesis.
So if p-value is lower than alpha, we reject the null.
Oh, okay.
Does that make sense?
Yeah, I'm gonna write that down.
So that's what they say in the video. What helps me remember, it doesn't really rhyme, but he says it. It goes, if p is low, reject the null. It doesn't really rhyme, but it helps me. Okay.
Thank you.
Sorry, guys. Cool. All right. Came out to the same thing. Okay, cool. All right. Number 11, we got 0.995. Number 12.
We got failed to reject.
Failed to reject. Good job. You decide to try another alternative hypothesis. This time you use mu is greater than, or mu is less than 40. Keep the same level of significance. Did p-value increase or decrease? P-value decreases. Does that make sense?
Yeah.
Because instead of a two-tail test, now it's just a one-tail. So it cuts it in half. Okay. One more question in, right? Yeah. Oh, not even close.
3 more.
All right. Oh, yeah, one of them's like a half one. What decision did you make? Wait, didn't it just ask that?
Yeah, but now you've increased it, so, or decreased.
Oh, yeah, let's see.
It's
So
still way above alpha.
Yeah, yeah, it's still like well above. So yeah, we still reject it.
Failed to reject. No, you
Failed to
failed
reject,
to
yeah.
reject.
Yeah, that's what I meant. I hate that verbiage, man. I hate it.
Okay. Now construct the 95% confidence interval of the true mean wait time between birth at the hospital. What is the lower limit of this confidence level?
Okay. So now we're going to do our formula for the margin of error. So we have our t-value of 0.006.
So
we're looking the margin. So for the margin of error, it's t times what was the standard deviation? Was it 36.356?
Oh, the standard deviation is 36.3558. Yeah, 356.
Okay.
Yeah.
So wait, are we thinking?
And so we're finding the margin of error, then we're plussing and subtracting it from the mean.
Okay. So we're. Hold on, I wrote down my equation wrong. Okay, so we take t, and we're timesing it by the standard deviation over
21 squared. Or sorry, square root of 21.
Okay.
Wait. So for 15, the
Wouldn't
mean.
T be 95 though? Or whatever that is?
Wouldn't T be what?
P, isn't that 95, right? So we put 95 and where P would go. And then we get it.
We're T.
Because it's 95. Because, so, are we going to get, okay, so
Oh,
it says,
sorry. Yeah, not 0.006. We put 1.96. Sorry, that was my mistake.
do we highlight in between or do we highlight the outside?
On this one, we're not highlighting anything. On this one, we're not even using the applet. This time we're doing the formula, the plus the margin of error, then subtract the margin of error.
Because
so,
T, no, but wouldn't you need to, no, because it doesn't make sense. It's 95 would equal P, right? So like with the equation, wouldn't it be so you put where it says area, you put 0.95 and then you're getting a new t-score. Right?
No.
Why are you not getting a new? Yeah, because it's a new confidence interval.
Yeah, that's not how I would do it. I would do it a different way because I would take point once, what was it? The 0.196 and then times it by standard deviation divided by square root of 10. You do it your way and I'll do it my way. We'll see if we come out with the same answer because I have the answer here from plugging into the spreadsheet and I just want to see if I get the same thing.
Okay.
Someone's breathing into the mic pretty heavy.
I know this is wrong, but I got 40.0000181.
For what?
The lower.
No, yeah, that's not. I don't think that's right.
So what do we use for T? Is it the 0.006?
Yeah, hold on one. No,
No.
I'm trying to. I think we used 1.96 because it's 95%.
Yeah.
Like the inside, not the outside. Anyways, we'll just calculate it out and see what we get.
Okay, I got 24.497989.
That's what I'm getting. But the system that I'm using, it's giving me the exact number, but one number less. I don't understand why it's doing that.
One number less than what you have?
So I'm getting the same thing you're getting, but for some reason it's giving me 23.499 and then 56 instead of 55.597. Huh.
All right. So I got 23.50334582.
So I'm getting 20 on my system. I'm getting 23.499. What the freak?
All right.
Going? All right. Let's go through my notes real quick.
Okay. I'm gonna do. Okay, can you guys see that?
Yeah, hold on. I'm not even looking.
Okay.
Because I know what you're doing. I'm just trying to think of which way is the correct way to do it.
Because I took that and then I did that t-score. I used that as my t-score.
Okay. So, and what was your answer?
I got 23.50334. And then blah, 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 blah. I got other numbers too, but if we're supposed to do the outside, then that's where, like, then I get the point.
No, yeah.
036.
No,
You guys are
I think each
so I'm
way.
trying to figure out.
I think each way is a right way of doing it, but they're all so close in number. Like they're all like at least one number apart. It's so bizarre.
Okay, do we want to just each punch it in and see who gets the closest?
Yeah, I think that's what we should do. We each punch in our own number and see which person came out to the right answer, and then we can share it with everybody.
Okay.
So Seth, which number are you putting down?
0.
For number 15?
What?
No, I'll put in the 24.5, I guess.
You're onto the
Yeah.
one decimal. So because then I did it without the because I got similar to what he got, but that would have been if I was using this one versus the other one. The normal is the one with the degrees of freedom.
Okay, and I'm going to put in 23.5 and then
Stop sharing my screen now.
56.
Anyway, stop sharing my screen. There we go. Okay.
All right, everyone ready to submit?
Wait, don't we have number 16?
Yeah, I did.
Oh, we're not okay. Hold on.
So I'm putting 24.5 and 55.6.
Yeah, I'm doing 23.5 and 56.6.
Okay.
And I'm doing 23.5 and 56.6.
Oh, you're the same as Seth.
No, same as you.
Yeah, I got the same.
Okay. Well, good.
What? I missed a question? Entering a number invalidly. Hold on. Where am I doing it wrong?
Wait. What are you putting in, Michaela?
Hold on. 56.6.
Okay, that's
So
just
I got 100. I got 100%. Okay, so Seth, plug in yours how you have it at the 24.5 and the 55.6, and see if you get 100% as well.
Okay. 24.5 and 55.6.
I got 100%.
Yeah.
So I need, is that what you're saying? Just kidding. I'll do it.
So for question 15, put 20, how you have it. You have it as
Yeah,
24.
24.5 and then 55.6. I will.
And then submit it and tell me what you get.
I think that's really weird that we all got the same upper letter, but we all got different lower ones.
It's not necessarily weird because each way you do it, the calculation throws it off a bit because there's like a couple ways to do it, obviously. So I think that,
it gave me 0.5 on each.
yeah, that's what you get because they're
That's
only
the
worth
total amount of
25.
Oh no, I got 0 then. Yeah,
What?
0 out of point. Yeah, so I missed them.
You missed both?
Wait, but didn't you get 55.6 as well?
Yeah, for question 16.
That's what we got too. How did we?
No, you got 56.6.
Yeah, we have 55.6. That's what you have?
Yeah, that's what I put.
Okay. So
Wrong, because that's what we got. I got it.
yeah, so Michaela, your way of doing it is correct. What did you do for 15, Michaela?
Oh, I did.
No. What was your answer? What was your answer?
Oh, I got 23.5.
Okay, and then 56.6?
Yeah. Is that not what you
Okay.
guys got?
That's what I got. That's what the system gave me. But when I was using the formula for Z instead of T, I got what Seth got. But I guess we can't do that because we have to do it the way you did. And your way of doing it was right. So you just did the formula twice. Michaela, can you make your screen the applet again?
Yeah, give me just a second. On there, but
Okay.
then
So
I use
what
that.
you did, so did you do 2.086
Mhm.
times standard deviation of 36.356 over
The square root of 21.
square root of 21, and then you did the same thing but with just a negative 2.86?
Yeah, I mean, and then I got whatever the answer was. I added that and I subtracted that from the mean, which was 16.544.
Okay.
Wait, so as soon as I'm done, hold on. I'm going to see if I can understand that as well.
Here, I can. Let's see if I can. I don't know what I'm trying to do.
So that was the correct way to do it. So, because on a lot of those lessons, they just said plug it into that spreadsheet and then see what pops
I didn't
out.
even know there was a spreadsheet. I didn't even see that. Why does this stupid thing not work? Okay, now. There we go. Okay. So I did 2.086.
And you got the 2.086 by typing
So it
in.
said,
95 for the area.
yeah, because that's what it was saying. It was the whatever thing of 95. So I clicked there. But you got to remember that you have the degrees of freedom, which is 20.
So Seth, how we were doing it for the formula of the z-score when the standard deviation is known. So that's why we're off just slightly.
Okay. So if I just changed it to a 20 instead of a 21?
No, that won't make a difference.
That's not what I want.
It may actually. Hold on.
Anyways.
So number 15 is 23.5 and 16 is 56.6.
Mm-hmm. Okay. Am I done sharing my screen now? Are you guys good?
Yeah. Okay. So do we all get everything figured out?
Yes.
Okay. Alrighty. Well, good job, guys. That was both of them. So
Whew.
we're all set.
Okay. And you're gonna post
any
it?
other questions? Yep, I'll post it.
Sweet.
All right. Good luck next week. I think what we're learning so far is so similar to everything's so similar to each other. So I think it's a little bit easier so far than last unit. So hopefully it continues on that path. So, all right.
Yeah.
Good night, guys. Have a good one.
All right, you too. Bye.